All right, I would now like to introduce our final speaker of today's innovations, Matt Monroe. He's the Senior Sales Engineer of Telematics for AMCS. Matt has been with AMCS since 2016. He has extensive experience in route optimization, as well as operational procedures and processes. He's also previously held positions as the head of development and operations with large-scale distribution and transportation companies. Matt, I'll turn it over to you.
All right. Thank you, Mallory. Good to be here. All right. So as we get started today, again, this is around how AI is impacting waste management. And to just kind of go through a little bit of the agenda of what we plan on doing today, just do a slight introduction around AI and how it's being used in current systems around the globe today. And then we're going to focus in on exactly how it is used to combat that overfill and contamination through our AMCS Vision AI solution. So everyone has heard the term AI. It seems to be one of those newest buzzwords that you hear going around every day. But what does it really mean, and how is it actually being used to make a difference? Here we're showing some examples of cameras and AI solutions that have been used in the currently being used in a wide range of technology and service sectors today, with many more expanding every single day to try to see how they can utilize this cutting edge technology. So metaverse and gaming, and for VR or virtual reality, anyone that's a gamer knows how this works. It's the virtual AI inside the system. That's the smarts of your competitors going against you when you're playing against the computer. In healthcare, to identify medical conditions and help reduce anomalies faster. And this is something that we see being used in a wider and wider scale now, where AI can compute large amounts of data faster, so it helps get to that common denominator, that delta, quicker. In sports, we've seen this used. You can remember those live events, or if you've watched baseball or football recently, when they're talking about velocity of the ball and how far he's run and his speed. All of that is being calculated with AI and cam assists to be able to bring us that. And then, of course, when we talk about automotive or autonomous driving, Tesla is a very recognizable name in the industry of automotive, and they've been applying this artificial intelligence to their autonomous drive vehicles for years now. And we see this being incorporated in a lot of these self-driving taxis and things of that nature too. But today we're going to explore how AMCS has utilized AI to mitigate a couple of very common problems, especially around waste haulers. First one being contamination in the recyclate stream. How do you identify that contamination, where it's coming from, and then obviously how you want to prevent that from occurring in the future. And then the other would be overfilled containers, how to accurately identify and track where they're coming from, and then also be able to have quantifiable proof to go back. And this can actually even translate, as I'll show a little later on, into some significant revenue generation. Lost revenue, you're dealing with those disposal fees, but you have to be able to charge for them as well. AMCS Vision solves these struggles, and it does it in a passive way as not to disturb or add to the driver's workload throughout their day. So this is something that you install in the system, and it's completely autonomous. The driver doesn't even know that it's there, or doesn't even have to interact with it in any form. It's a completely autonomous and allows to capture the solution, or excuse me, capture this data in the field that's so vital in making decisions. So what I'm going to do here is I'm going to play a little video that kind of gives a little bit of an introduction of, or an overview of AMCS Vision AI. And then I'm going to actually jump right into the actual environment, kind of show some of that data and how we're tracking that data.
Introducing the new AMCS Automated Contamination Management Solution. The contamination of recyclables creates significant financial and environmental costs for recyclers, such as expensive landfill disposal, reduction in sale value of recyclate, and expensive downtime in recycling plants. The conventional ways to prevent contamination are not effective, as container inspections are slow and costly, and tipping inspections cannot identify the source of the contamination. We believe that the challenge of contamination calls for a highly automated solution to fully manage the detection of contamination. Each vehicle has a DVR system to record video streams of the container contents as they are emptied into the vehicle hopper. This stream, along with the date and timestamp and container GPS coordinates, are sent to the AMCS contamination portal in the cloud. Our advanced analytics tools, which are based on the latest AI and machine learning technologies, will identify and score any contamination. We also identify the likely street address of the contaminated container. We now have the necessary information to have a productive engagement with the customer. It provides a full suite of reports, KPIs, and dashboards to drive the continuous improvement of your recycling.
Okay, so as that little short video shows, just kind of surmising how that system works and really what it entails. It's a relatively simple from a hardware perspective on what needs to be installed onto the truck. You're talking about the camera system. This is the video stream that we use to capture that collection event. So usually between a 10 to 12-second video, depending on how long it takes to do the tipping. And we capture that material as it's flowing into the hopper. And we break that down by frame. And this gives the AI engine the ability to analyze that material in motion and from several different angles, which means that it would give a much more accurate portrayal of any potential contamination inside that hopper. That's then fed up to the cloud environment where it actually gets analyzed. And then we have that admin division AI analytics portal that we'll go into next and actually see how that data is captured and crunched and how you can dissect that data and give yourself quantifiable evidence to go back to customers. But ultimately, most important aspect is being able to identify exactly where these events are occurring. That's the most quantifiable element of this. You can then use campaigns or any kind of knowledge-based pamphlets or any of that information to try to correct or mitigate any of that behavior that's derogatory to the environment. So let's actually jump right into the environment here. And this is exactly how it would be implemented from an end user perspective. You would log into this, and then it would take you directly to, there's a bunch of different fields here, which we'll discuss, but inside the system, it's taking me to a dashboard here, which is allowing me to select different waste streams to be able to track different events on a weekly basis or monthly basis. I can sort through time periods as well. I can get into a little more analytical phase where I can go in and break it down, not only just by events, but exactly what type of contamination I'm actually accruing over a specific period of time. And many times this is kind of a vital aspect to know exactly the severity of the contamination that's entering your recyclate stream. And then ultimately being able to analyze this data in a more collective environment and be able to use that. So we have some pretty extensive reporting tools, which I can't go through, won't have time to go through all of them today, but just to kind of give a little bit of a snapshot around contamination views. And you can see we have different event scores. I can do some filtering and sorting. I can set up reports to run on a reoccurring rate with selected information or selected criteria in those reports that I can have at my purview and my fingertips when I need them. You see here where we're looking at contamination event, and by clicking in it, it's going to actually show me that event for this particular stop or site location inside the system. It's even going to show me the surface area of that contamination. It's not always just being able to identify the contamination, but it being able to identify how much of that contamination is included in a particular stop. I can switch this over to overfill. Overfill is going to tell me whether these containers are whether they are overfilled or not. It's a binary type system. So simply being able to, let me just scroll across here and get to some of my events here. Results standpoint, you see here I have the ability to manage my columns and put them in the order that I see fit. And as these pictures load up here, we'll see some content come up. So as you can see here, the AI algorithm is taking a look at this. And in this particular environment, this is what it's looking for. It's looking for the container to be filled above this top criteria of the container. Look at a different one here from a different angle. You can see it's identifying that. It's either binary, it's either overfilled or not overfilled, and then it captures that information. So this is, again, looking at this in a collective date range. If I want to get into more of an overview for like a particular contamination or overfilled, I can drill into my customer data that's inside the system, or not the customer data, the event data, and be able to drill into some areas and see exactly the events for a particular site location or customer location. And again, that same type of information is being portrayed to me. It's giving me a score summary. Again, different types of material inside of a recycled stream might have different impact, and they might be more nefarious than others. And therefore, we weight them by how many things are in that container, and then by that type of material that's in that container as well. So you can see here, I can zoom into it, even zoom in a little farther to get a little bit more detail on that. I have the ability then to either download the image or download the PDF. If I download this PDF, what it does is it's going to actually show me the customer there. It's going to actually populate automatically for me, show me the site location for this particular customer, and then the time and the date stamp on it with the event score and the images to go along with it. So this is quantifiable proof to be able to take back to a customer and be able to mitigate it so they understand that these materials are not allowed to be in that particular recycled stream. So hopefully that'll prevent that from reoccurring in the future, or to be able to create a running dialogue as well, so that if this continues to happen, you now have some restitution to be able to go back to the customer and say, listen, we're going to have to start charging for these contaminations, because we have to dispose of them, and there's disposal fees outside of the material, as well as degrading the material type that you're collecting. Get that out of the way here. So overfill contaminations, we just showed that. Another area that's become very useful is the heat map. This is a thing where I can look at everything. I can go by contamination for this. I can separate it by waste streams if I wanted to go into an organics, corrugated cardboard, all these different things. I'm just going to go into corrugated cardboard right now, and you'll see where it allows me to do a range. And before I get into this range, let me explain what that range means. So if we look at material weighting, this is where I'm outlining to the system exactly, depending on the type of recyclate or depending on the material that I'm collecting, what is considered the contamination and how severe it is. So if I go to corrugated cardboard here, you'll notice that we have a lot of black plastic, white plastic. White plastic is less severe than black plastic. And so it adds up these depending on how many events that it sees inside that container and gives it a score. If I change my material type to organics, you can see we have a different set of criteria to it. And again, if I go back in and let's do full general waste, we can see I can have different criteria for general waste as well, for areas that I would want to be excluding or consider contamination. So this is where it's getting that score, if you will, for these material types. And I'm deciding how much is the severity. Do I want to have everything listed, every single type of event, or do I want to only take the ones that are between, a 9, 10, and the most severe, which is a 30? And then I post those results, and I will get a heat map, which is showing me on the map where these types of events have occurred, and I can zoom in and look at them and see, like, maybe here I need to have some kind of an educational campaign because we're seeing a lot of contamination in a particular area. I also have the ability to drill directly into that account. So if I see something, I can drill directly into it and be able to see exactly what events were recorded over that time frame for that particular route. And again, that all important surface area of what those are. Score being a 28 on this, and then the surface area being 15. You can see the black plastic bags that are in there, and then a blue plastic bag that it's identified here as well. So having that available on the heat map, and again, I could go back into this, change this around, we'll look at overfilled, same metric, refresh the map. Let's grab my metric here. Change my event to. Oh, I need to get contamination out of there. There we go. Let's get this out of here. Let's go to overfilled. All right, of course, during a demonstration, it's not going to cooperate with me, but this would be showing that same that we were looking at for the heat map on the contamination, be showing on my overfilled events. I have that ability to go in as well and view just overfilled events here and be able to, again, by that binary, be able to view whether it was overfilled or it was not overfilled and be able to sort through that. Device mapping, this is an area, or excuse me, the vehicle assignment. This is an area as well where many organizations have multiple vehicles, and each of those vehicles might take or might collect different waste streams or recyclate streams on a different day of the week, or even multiple ones on the same day. So you can configure in our system here what the type of waste stream is so that the algorithm obviously uses the correct methodology to identify whether it's a contamination or not. So this can be planned and set up inside the system. The nice thing about this system as well is if I have a mistake or if someone forgets to set up a vehicle in a particular manner or assigns the wrong type of material to be collected for that day, I don't lose all of that data. I can come into the system, I can simply click on where that is, and I can edit that material type for that particular day. It'll go back through all of that archived history that it acquired and then recalculate based off of the new algorithmic process that I have put forth for it. So this allows that data to be much more accurate and be able to recoup that, even if there is a mistake on what I planned on analyzing throughout that day. So it makes that your data that you're harvesting makes it much more, keeps the integrity and makes it much more precise. We also have the ability to do the media review. And here, allows me to take a particular waste stream, a particular vehicle, and break it down by the vehicle type and be able to see those events in there. So I can look at a particular date, look at a particular area, and have those events load for contamination or, again, around overfilled, and have it be able to show me those events based in that time parameter or that time filter. There's also the ability, this is that event recovery I was talking about. If I accidentally scanned incorrectly over a period of time, I can come in here, enter in the dates and time, and then have it reprocess that. But QR coding is another area that we're using AI on this solution. And again, one of the major areas of that this is an improvement is it allows you to utilize equipment for more than one purpose. So the hardware can be utilized to do more than one thing. So QR coding, one of the benefits to QR coding is the ability to scan a QR code from a considerable distance with a camera. And also, if the QR code gets degraded by, a third, 33% or 35%, it still will fully scan. So what that does is it makes it a much more accurate form of scanning, very close to what you would have with RFID. But with RFID, you now have to maintain the sending units on the containers themselves, and then also a reader on the vehicle itself. So added maintenance to be able to added cost of that hardware and added maintenance. And again, there's only so much space on these trucks as well. So we've designed this to be able to utilize the existing equipment on here. And what it does is it'll literally allow you to, as it's scanning as these containers are being collected, it's scanning that QR code to associate it with the proper customer record that is on file. And if there is a discrepancy, or if there's this is an example of 2 homes. This is where the container is actually located. And it's saying that based on where this geography is, it could belong to one or the other one of these particular homes. And so therefore you can come into the system, mitigate that and reconcile it, and then make sure that that bin is being processed toward the correct address. So that QR coding allows you to match these container types to these customer events, and then also be able to have them serialized as well. And I think that's probably everything I wanted to show inside of the solution here. So let me go back to the slide presentation, quick time check. Yep, I'm doing good on time. So as we talk about the powers of AMCS and Vision AI, some objectives that we set out to attain by putting this product out into the marketplace. So automation at scale, it has to be able to be seamlessly grow and scaled to your organization. That's imperative in a digital age like today. And it also has to be easily implementable, to be able to get this up and running in a short period of time. This system is a completely agnostic system, so it can stand completely on its own, or it can be used to interface with our core ERP system, which is Platform, where we can then sync up with customer records, even do things such as facilitate automatic charges to customers for these types of events, whether it be overfilled or whether it be contamination. So having that information seamlessly integrate, being able to utilize that information in a more productive manner, in a more automated manner. Be able to be accuracy and repeatability. Again, accuracy is the key to any analytics that you obtain. So with the data, if it's not accurate, then the decisions that are being made off that data will not be helpful or beneficial to the organization. Being able to see and analyze trends, that's where the insight comes in, and create initiatives that can drive real change. So as I was showing with that heat map, being able to identify areas that need more attention than other areas, be able to focus those resources to those areas to, again, correct that type of behavior. And then lastly, that actionable information, having quantifiable information to be able to take to the customer or empower your sales rep to be able to go to the customer and say, hey, listen, you're continually overfilling this 4-yarder. We need to get you either another 4-yarder here, or we need to increase the service intervals for your site, because we can't just continue to keep picking up this excess material and having you overpacking that material. That creates some safety issues, which we'll get into a little bit later as well. Too far here. So with this passive automated scanning of each collection point, this will remove the contaminants, improve quality of the material between being processed by moving the identification of this contamination to the collection process. So instead of having to deal with this when it gets to the facility, you now have the ability to identify that in the field at those site locations and be able to take those actions to correct that and mitigate that. That means that you're going to have faster collections, because now your drivers are not going to have to worry about materials that are overfilled in the container or down stacking things, or having to worry about getting out of the cab and going and inspecting containers and not really being able to see what's at the bottom of that container. So being able to just take a snapshot of it doesn't really make it that efficient. This improves that resource quality. So for those that resale that material, ensuring that you have a more precise, clean influx of that material is going to allow you to get that processed and be able to resell it much faster. And then the safety element, as I pointed out, from a driver perspective, not having to handle material in the field. Obviously, there's litter that can happen because of that as well from overfilled containers, but also being able to identify this, all of this type of materials and contamination prior to it getting to the processing facility. Anybody that's had a MRF go down because of material that should not have been processed through it will definitely understand how meaningful it is to not have to deal with that, or to be able to rectify and mitigate that from happening again. The higher resource quality means faster processing, and then ultimately a higher resale margin as well, because you're not putting as much level of effort into it to get that material to a processed form. So some of the benefits, we'll just kind of skim through these a little bit. I know I've talked about a bunch of them already, but reducing that contamination at cost by being able to identify precisely where this contamination is taking place. You can then be able to have quantifiable information to confront offenders directly and mitigate any future. Educational system as well to try to educate customers so that they know exactly when they're in compliance or out of compliance. Better environmental outcomes by reducing the excess fuel for usage for repeated trips because of overfilled dumpsters or overfilled containers that make us have to break off and then come back to that route and deal with that material. From that, enhanced staff safety, reducing the drivers and other personnel from having to manually handle that contamination by removing it from the recycling stream at that source. And increase public trust and loyalty. Recycling programs get a tough rap sometimes, where the end users or the consumers feel like they're probably not really making any difference. So being able to track this type of improvement, where you can show, yeah, we had this many incidents last month, and this month we have X amount less, just improves that customer and public trust. So in this, we're just showing an example of one of our long-term customers that's utilized this in the field, and basically them just giving a testimonial about how it has really changed how they deal with their customers and how they process their routes and the efficiency of their routes. So you can see how they're basically talking about how it has directly improved and allowed that feedback to be provided to the customers, which has impacted them dramatically. When we talk about overfilled containers, there's environmental impact, safety impact, service delays, and financial costs to it. So I have a little graph here that I utilize a lot. And this is like a validation point, if you will, about tracking what's been going on in the real world. And you can see these two lines here of the solution, or the customer that we were dealing with in this particular incident. They had about a 10% report rate on overfilled containers on an average route. And so we put Vision AI in parallel with that. And what we found is that it was actually 20% verifiable overfilled containers on their route, which is a 100% increase. That equated to, around a $1,435 revenue generation for lost revenue that was not being reported before, and that's off of a $20 overfill charge that they were doing. So that's per week. So you can imagine if it's 20 trucks in your fleet, that's almost 30,000 per week that you're being able to identify in revenue, and that'll offset those extra disposal and tipping fees as well. Ultimately, trying to change that behavior, but at least from a monetary perspective, you're not losing that revenue or having that revenue leakage. So this is an actual use case that we have in the field. And then some of the real ROI metrics that we've accumulated over the years. This just drives home that the value to the system. Again, these are not typos. This really is the way the solution acts. It is really something that just on the overfilled element alone, it ends up paying for itself, the entire solution, just from the overfill aspect of it itself. And in closing here, I will just reiterate what we've kind of gone through as far as the positive aspects of this Vision AI solution. The automation at scale, again, being able to scale this and grow as you grow and you add more vehicles, it's very easy to implement this system in there and add it to the system. Accuracy around the data that's being pulled in is a major aspect of it. And then insight, being able to really be able to see what's going on in the field and being able to attack those contaminations and overfilled at that site, being able to have something to go back directly to those particular customers. And with that, I'll leave this on the screen here. These are some QR codes that you can easily scan, get a little bit more information about the solutions that we've just talked about. There's also an email address in there where you can reach out and schedule a demo if you want to be able to see more insightful demo with a little more time to discuss the functionality. Be happy to do that. And with that, Mallory, I'll turn it back over to you. I think we got, 5 minutes? I think I timed that perfectly for some questions at the end.
Yeah, we got a couple questions for you. Somebody asked if this could replace waste audits in the future.
That is kind of the way we're looking at. Again, automation always, when you have the human element in play, it's unreliable. You can't really rely on that data. So when you have something that's automated as this allows you to be able to track every single event that happens and be able to have that quantifiable information and data that you can rely on, because nothing's falling through the cracks.
Great. And how does AI help waste management companies go from simply collecting fleet data to using it for more strategic decision making and improving that frontline driver productivity?
Yeah, that's a great question. And I think probably the most impactful element is the passive aspect of it. So by the driver not having to interact with it, you're not relying on that human element, first of all, and you're not distracting them from what they need to be doing throughout the day, which is driving safely, customer service, getting to these stops on time, and navigating some roadways that can be pretty treacherous at times. So by having that passive ability, this really takes us to the next level. Now you have much more information. We've correlated it in a very understandable and digestible format and made it very easy to translate that data that you're acquiring in the field in real time and be able to put that into the customer's hand to be able to change behavior, educate, or in some cases, have to discipline through a monetary recovery. But being able to have that information that really transitions the responsibility from the driver and puts all that information handily in the organization's hands without having to reconcile a lot of different data elements or data components.
And I know earlier you had mentioned, leveraging AI to achieve cleaner routes and detect contamination. Can you explain a little bit more about how that process works?
So it is literally taking the process flow works where it's literally looking at that contaminant or looking at the materials that are in that container, not only just at the surface, but as they're being dumped into the hopper. So it's literally taking about a 12-second video. It's then breaking that down into individual frames where it can see different items, different objects at different angles, and identifying it through an ever continually growing machine learning process. That is another aspect I should point out. If you were to implement this tomorrow, you're not starting from scratch with an uneducated AI tool that has to learn a lot of stuff. It's continually identifying more and more different material, packaging types, etc., throughout the day. And so with that ongoing correlated education, it becomes very, very efficient right out of the gate for even for smaller areas or very high density areas. And so by that, you're then able to get to actionable information and really be able to trust the results off from it.
Great. And just to kind of close out, what actionable insights can AMCS provide to help attendees increase their margins, operate more efficiently and stay ahead of the fast evolving AI landscape?
Yeah, that's another great question because again, it is cutting edge, bleeding edge technology. I would say one area that we've really had a lot of breakthrough or very I guess, even-keeled understanding is when it comes to those overfilled containers and how that really affects an organization. You're dealing with that. You have to deal with that excess waste. So you're still dealing with that extra disposal costs, but not knowing where it came from or relying on human interaction for a driver to be able to take a picture of it, be able to identify like how much of it is there. Even a 3% overfill rate that goes undetected is enough to cost one vehicle, close to $2,000 a week of extra costs, material costs, et cetera. And when you quantify that across, multiple vehicles that are usually in these organizations, it adds up very, very quickly. So I think that's the easiest common denominator. That's what I would consider low-hanging fruit, something that we deal with on a regular basis that really is very binary. Contamination is sort of a perceptive type of a situation where how much does that really impact me from a monetary perspective might be a little bit gray. But when you're talking about overfilled, it's pretty black and white where, if it's overfilled, especially if it's egregiously overfilled, having that proof to be able to tell the customer, hey, this is what we have to do. We're either going to go to another container. It just generates revenue, and it's very easy to generate revenue just off of that one simple model.
Well, thank you so much for taking the time today, Matt, and sharing your insights. If anybody has any questions, Matt's info is up here to follow up with him afterward. And thank you once again for your presentation.
You're very
I want to
welcome.
thank everybody, who attended today's innovations. And as a reminder, a recording of this event will be available within about 5 business days following the event. I'd like to once again thank all of our presenters and sponsors for their support and participation in today's innovations. We also hope to see you at one of our upcoming conferences. So this fall in Chicago, we have MRF Operations Forum, the Paper and Plastics Recycling Conference, and the Corporate Growth Conference. So we hope to see you all there. And for more information on those upcoming events, you can visit recyclingtodayevents.com. And thank you once again for taking the time out of your day to attend today's innovations. And I hope you enjoyed the rest of your day.